All right, let's look at some Commander Keen version 5. I did make a save game editor for 6, and now the point is, or the goal is to add support for version 5, for Keen 5 as well. So let's start our reverse engineering. Okay, let's start by adding a check for the God mode. I do have to look up how to activate the God mode though, because I don't know that by heart. Keen 5 God mode. So debug mode first. That's so we're going to search for the value 0 first, of course, because the toggles for the God mode is going to be 1 boolean, which is now at 0, presumably. So once we activate the God mode, we're going to put that on 1, and then we'll find the value. So apparently you have to press A2 and enter, and then F10G. Okay, A2 enter. Okay, and then F10G, God mode on, and now we search for A1. All right, and I'm going to toggle it off again. Okay, so this one is flickering here, so just to check again until that leaves. Yeah, okay, and then we'll toggle it off. Okay, so this is the one clearly that has that is the God mode toggle, because if I, so yeah, now it's off, so I do this one, yeah, and if I toggle it on again, then we see that one flips to 1. Okay, so let's add that to our symbols. Don't know if that's big enough. Let me see. Probably not. I have to gonna peek at 1.5 here. Let's copy this one and plug that in here. Our base is going to be, for the God mode, is going to be 447E. And then our address is 003. We can adjust those addresses later, of course, to see when they are or how they fit in the segment, in the correct segment that the game uses. So God mode, and that is a bool 16. Okay, and now we will reload this symbol here. Of course, I'm going to restart. That's the easiest one. Right, so we have our God mode on and off. I think the jump cheat is right next to it. So if you go look in the memory here, this is our God mode. I think this one is going to be jump cheat, as it was in Commander Keen 6. So F10J, I assume. Yeah, so jump cheat on, and this one changes to 1 as well. So I'm going to use those a lot, because otherwise I have to play the game like for real all the time, which I can't really do. So we have done address, what is it, 5, I guess? Yep. 5 is jump cheat. Okay, so both are on. And now we're going to have to look at all the symbols here for the game state and for the entities, as we had them in Keen 6. So yeah, this is, I'm assuming this is going to be pretty much the same game state or similar as in Keen 6. Obviously, we have different levels. We have different names of levels, but that's irrelevant. We don't have the sandwich and the rope and the rocket and the pass card and stuff, because it's a different game, of course. We have other stuff. So let me, well, to find the game state, let's save a game and see if we can search in memory for the values, right? So I'm gonna go in level. It doesn't really matter, of course. And I'm gonna save a game, just 1. And I'm going to open that in a hex editor. Let me go to the correct folder here. In Keen 5. and that's save game 0 today at 2. That's correct. Open this one. Let's make this bigger too. Oops. So we do see similar things, as in compared to the Keen 6 save game, as we have determined in the YouTube video. So we have a magic word, CK5. In this instance, it was CK6, and of course in Commander Keen 6. Then we have a version, a game version, implying that you can't open a save game made in another version. And this one was our has been overwritten boolean, which we don't really know. Then we have our save game title, and then here our game state starts. I assume around here somewhere. Yeah, the CDAB. That's the start of, or around the start of the level data. So we should look for a block like this in running memory, I mean, which we can do, of course, by going to memory and searching for, let's say, CO18, like the first couple of bytes here, CO18, 0056, and then a couple of zeros. And we don't find that. That's weird. Oh, did I make a mistake here? No, yeah, 56. Am I in the wrong segment here? I mean, it should be in the correct one, though, no? Oh, now it finds it. That's a bit weird. 0813. Was I not in the correct segment here? Yeah, okay, so never mind. So this is the one. This is the one, CO1856, and we end up with 2 3s here, which is probably going to be lives and difficulty, as it was in Keen 6 as well. So at least we found the start of our game state. As we knew in Commander Keen 6, this was the map position, the X position, and the Y position of the map where we left off just before we entered the level. And then we end with, I think it was difficulty and amount of lives, the two 3 values here. So let's take this address, which is at 3813793A, and let's add that to our symbols list. Here, 793A. So let's go to 1.4 here. And then we're going to have a different base here because it's in a different region of memory, which is fine. So 3813 is the base, and then we go to 793A for our game state. I'm going to make that a struct. And we're going to copy over the struct from Commander Keen 6, which is going to be incorrect, but at least we'll have a starting point. So structs, what did I copy? Yeah, I copied the entire thing. And then we'll have to clean it up. What did I copy incorrectly? Oh, there's comma here. I'm going to have to clean this up because I don't have my enums. I mean, I guess I could copy. Let's just rename that because that's not Primulus Zax, of course. I'm going to remove these as well. Why is it not formatting my? Oh, is there still an error in there? Yeah, there's an error in there. My window is too big. What's the error here? Enum, so I have, oh yeah, the fields is an array, yeah, that's closed, and that's closed. Is that not? Okay. Let's clean this up. And then all right, so we have our 25 levels, which are booleans. We have these are going to be wrong, I guess. Score extra vivas do not exist in keying 5. Sandwich rope, rocket card, pass card also won't exist. That's fine. So these enums can go away. Of course, they definitely don't exist. And then we have the gems and the location. The locations I'm going to copy. They are going to be named differently, but at least we have a thing to put them in. So the difficulty levels are going to be the same, of course. What did I copy? Only the contents here. So we have 2 difficulty levels. Of course, these are going to be having a different name. But that's fine. Yeah, and the entity point, we don't have entity pointers yet, so just make that an unsigned 16. And let's see how that looks in the game in RAM. Just an object with a fields array. What did I do wrong? In nums. That doesn't make sense though, that error. Oh, is that an array? Oh yeah, it is an array, I guess. No, it's an object. That's correct. Oh, did I put that in the wrong thing? Yeah, that closes. Let me make it a little bit smaller so I can see my balancing here better. Yeah, the structs end here, I guess. And then this one is extra. Yeah, it's like that. Yeah, that's better. So we have our game state in memory now, but it's going to be wrong, of course. So map positions are looking to be correct. Then we have our levels, that's the same. Score and extra also seem to be correct. Let's go back to the game. And then we can get the status screen here. So score is 0. Let's change that. That does not update immediately, meaning that's not a score then. That's weird. Let's get a point. Am I in God mode? Yeah, let's get a point and see what changes if I pick up a thing here. Yeah, that's 300 now. That should have updated, I guess. Yeah, now it updates. That's weird. Oh, it doesn't update when you're in the status screen. And now it does update. Okay, so that's the score. Then extra is 20,000, of course. So if I put that on 400, and I open it again, that's on 400 now. And if I take a ping, I get an extra life. Yep. So ammo is 5. Yeah, ammo changed into 4. That's correct still. And vivas don't exist here. So we have Vitalin or Vitalin. We have a key card. Let's change this value. Yeah, is this one. Is the Vitalin or whatever it's called. Yeah, that's Vitalin. So instead of vivas, we have Vitalin. Okay. Now these guys don't exist. Sandwich rope and rocket pass card, rocket location either. And we don't have the green gem here visible, so that's incorrect either. Oh yeah, if you look at location here, so location and lives are one next to the other. So location is on 4, which is, I assume, the lives. So we have to go 1 down. So I think we have to insert 1 here to push it down. So then we would be in location 1 and have 4 keys and difficulty 3. Yeah, let's push 1 in these guys here, and let's rename them as well. So we actually have unknown 1, 2, and 3 here, and 4, I guess. I'm going to give them U16s. I'm going to introduce a 5th to push 1 down. And let's see what we have now. Okay, we have our unknowns. And then this isn't correct. Oh no, I pushed 1. It pushed up now. Oh yeah, I shouldn't push up, I should push down. Okay, meaning we have to remove 1, not add 1. It was the wrong direction. So location is now 1, lives is 4. Let's put the lives on 5. That doesn't change immediately here, but it does change on the top left corner. So yes, this is indeed, and we are in hard mode. And the pointer to a moving platform, that's the pointer to an entity, but we can check that out. If we do stand on the thing here, yeah, this becomes a pointer. So that's the same thing, apparently. It is indeed the same. That means that the gem should also work. So if I give myself a red gem, yes, that works. Then the yellow one, yes. The blue one and the green one. Yes, okay, those are correct. So we have 3 unknowns left then. And that would do it for the game state then. Oh, we have a key card thing. Maybe one of these is the key card. Let's put it on 1. Yes, that's the key card. So that was unknown 1 is a key card. And let's make it a boolean so we can have a checkbox. Because I assume that's just an on-off value. Yes. What else do we have? I don't know the game by heart. Like, it's a very long time since I've played this, and I don't know what all you can get and like you can find in the game. But we'll figure that out later. I mean, I guess I can put it on 1 and see if we do get something. No, not really. Not at least shown in the status screen. We do see our name of our first level though, which is ion ventilation system, which we can add as well. I'm going to put this one on 0, and then we're going to put the first location name in there, which is ion ventilation system. And I'm assuming then that's finish level 1 would be finish level ion ventilation system, which we'll do now. And then we'll see if the boolean shows up here. Wait, did I not put the location? Locations, oh no, not 0. It's level 1. Yes, so we are in ion ventilation system. Let's finish the level. I think we can go up here. Yes. So we assume that this one gets ticked, gets checkboxed, and then we'll change our location to 0. And the Omega Matic, that was the name of the map overview. That's Omega Matic. And we did indeed get this checkbox for finishing level 1. And now we are in Omega Matic. Let's see. I guess we'll have to play the game a bit to see if we can we can figure out what these two guys are. I doubt we'll find that in the first few levels, though. I also don't know where to go. It's been too long. But that's fine. Give myself some gems here. Okay, that's another gem. All right, I have to open this one. Is it up here? Yes. And then the blue one up here. Oh, there's the key card which we have. When I click this. Okay, and then we just have to find the exit. I have no idea where it is. Oh, it might have been down there. Okay, I have to turn the jump cheat off, I think, to drop through the thing here. Oh, this one is just the platform. Yes. So our unknowns are still on 0, so it's not something we have here. Did I not check? I forgot to notice the name of the map. Damn. I should have looked at that. Maybe we can find it online. Okay, it is online, of course. So I'm assuming, oh, security center. It was probably security center then. That would have been security center, I'm assuming. So let's copy that. And then that would be defense tunnel Vloek. The next one. Well, it depends because I think there's multiple now, right? You can do this one or let's see. Defense tunnel Burr. Okay, so this is a different one. We have to look at the number. Or is that a typo here? Oh, no, it's this one. So defense tunnel Burr is level 5. Okay. I think I wrote it correctly. Yeah, BURRH, yes. Also something, I mean, a level that probably doesn't have anything that fills up our unknowns. Not sure, but we'll have to go through quickly and see if we can find something. Is it this one? Yes, it is. I assume that's the way out. Nope, not this one. Where is this? Oh, here. Okay. Gem red. Oh, yeah, that's the exits. Can we go through here? No, I'll just take the door, I guess. I think we can go through. Yeah, we have the keys, of course. I have to turn my jump cheat off again. And get the yellow gem. Yeah, and oh, that's for the blue gem. Was there something more here? Yeah, let's drop down here. All right, here it is. We have to give ourselves the key card and we leave. Okay. I do also want to look at the entities though. This is Defense Tunnel Sora. And this is number 7. Was it? No, without an H. All right, and I forgot to add these guys too. These booleans up here. That was 2 is Security Center. And then 5 is Defense Tunnel Burr. And then we have this one, the current level, 7. Okay, let's try to finish this one. I'm going to give myself the gems already and the key card in case we need it. I hope this is the correct path. That's the key card was there, but it does seem to go on. Hope it's over here. There's a gem there, which will open here. Yes, okay. I think that was yeah, that's a dead end, of course, no problem. Oh yeah, we have to open these, this here, right? It doesn't give a message. Let's do this one. Oh, there's 2 here. Can I do both? Well, tunnel town. This is 9. Yes, 9 is tunnel town. I'm assuming these are going to be correct in the correct order. Let's finish this one. Another gem. And hopefully the exit here. But we do need a key card. All right, that was level 9. Oh yeah, this one goes on, I guess. Let's do this one first, because that's also a dead end. This is Oh, that's the tunnel fluke. Okay, that's number 3. All right. There's the key card. I have to go up, I think, because there's a door here. And that's for a gem. Oh, there's another door there. Okay, good. And probably over here. Yes. With a key card. Yes. All right. So that was fluke. And now let's go more north. The Brownian motion inducer. Which is number 10 over here, location 10. All right. It's gonna be up here, I guess, then. Oops, this is a secret area. I see many doors. That's the other door. I have to jump again. And there's nothing here, of course. There's nothing at all there. Wow. I guess we haven't been here. Wait, isn't this the start? This is the start. What am I missing here? Damn. Am I that blind? Sure. I don't know where I'm going, but okay, that's where he came out. I think I went here, right? There was nothing here. That's weird. Yeah, there's no secret things here either. So we have to go up. Oh, did we go in this door? I don't think we did. This might be a gem or something. Yeah, that's what I figured. Oh, this is just for a gem. Great. I don't know where to go now. Oh yeah, I didn't do all of these, I guess. I think I went up the first one and not in this one. Should I go look here first? Oh, there's nothing here. I think I went in that one, right? Let's see what happens here. Oh yeah, here we are. Need myself some gems here. And then, oh, okay, this is, oh crap. This unknown 3 changed to 4. And I don't know, I didn't see it change. Damn, so it's definitely in this level, right? I'm assuming. Yeah, so definitely in the Brownian motion integer. Okay, so this is on 4. But I didn't see what triggered it. Damn, so we have to replay the level, I guess. Oh, yeah, oh, so okay, I already can see. It's the amount of things you have to break. So we broke 2 and there's 4. Yeah, of course. So I'm assuming I'm gonna replay this level, of course. So yeah, once this is 0, then the level ends. So 1 and 0, yes, and yeah. Now I'm assuming this is going to be reused for other levels where you also have to do fuse breaking. I'm not sure if that's the case though, if you have to break fuses in other levels too, but I'm assuming it is. So we're going to name unknown 3 is the amount of fuses left, right? So yeah, I think we figured it out. Let's now see if we can force that value to 0 and end the level immediately. So what I'm going to do is I'm going to go back. Can I go back to the ship level? I think I can, right? Can I go here? No. So in this version you can't go to the rocket level. That sucks because that would help us with fiddling with these values. I can force to go in certain. I can redo certain levels, but you have to reload the level. Can we now go here? Wait, so where do we go now? Oh, right, there's one more here, which I didn't see. Yeah, so I'm going to turn this one off. That means we haven't finished the level, so I can redo it, but I have to go into another level to trigger that. And in Commander Keen 6, we would just go back in the B with in the Mega Rocket level, which you could enter as many times as you want, and then it would reset the map according to these booleans here to determine what you finished or not. But that's fine. And of course, I didn't look at the name of the. Oh yeah, I can see it here. Okay, so neutrino burst injector. Which is this one. And we are in level 8. Okay. And we can finish this one too. Let's give every key and the rocket and the pass card, or the what is it called? The key card. No, where's the exit here? Oh, I see. We have fuses left is on 1. Right, so it is reused in different levels, right? So it's not just for the Brownian one that we just saw. So I'm gonna find the fuse and I'm gonna break the fuse in RAM, not by jumping on it. Does this go anywhere? Just, of course, just a gem that we don't need. I don't assume that is the fuse though. Let's go down here, perhaps. Oh no, that's where we came from, right? Maybe in here. Oh, there's a door we can open. And another one, I'm assuming. That's going to be this. Yeah, okay, here's the fuse. So yeah, we have indeed one fuse left. Now we're going to force this value to 0 and see if the level ends. I'm assuming it's going to. Okay, it didn't. That's interesting. So it's not a trigger, like the trigger's elsewhere. That's fine, I guess. Yeah, okay, it went to -1 now because I already put it on 0, of course. And of course, crap. Yeah, now I can't finish the level, of course, because it already, it was checking for 0 and it was -1. And now I can't finish the level now, which means I just can turn off God mode and die. Yeah, so I can't fiddle with the variable itself. Yeah. I do have to jump on it myself. Okay. It was down here, I believe. I'm gonna need all the gems again. Right, so the fuses lab does indeed decrement to 0, but I can't, it won't trigger the level exit when I just manually do that. Okay, so we still haven't seen unknown 2 yet, though. That's a bit weird that we haven't encountered that. But surely the elevator should now be open, right? Or no, still not. Did I miss another one? Yes, I missed this one too, I guess. Let's see what this is called. Energy flow systems. That's 4, I guess, then. It is indeed 4, yes. All right, we have two fuses in this level, apparently, which we'll have to find, of course. And this is quite a vertical level. There's just a gem there and nothing here. Yeah, that's just for the gem. Nope, not on there. Let's go left here. Okay. There seems to be a barrier here we might have to go through. Nope, we don't. Oh yeah, I can't drop here or my God mode will stop. Let's see where we end up here. That's just for that. I don't think I can. Yeah, this is the bottom of the level. I will die here. So where do we go? Oh, we can go up to. Oh yeah, maybe it's in here. Yes, it is 2 fuses. That's correct. So one of the 4 machines protecting the main elevator shaft. I assume it's going to open up now for the rest of the level. Unknown 2 still hasn't moved yet, which is fine. Okay, now this one should be open. No, why is it not open? And I still forgot one. Oh yeah, is this one perhaps? Brownian motion inducer. Okay, we've already been. Oh yeah, no, I had Oh yeah, damn. I unchecked this one. Yeah, that's why I didn't open yet. We have to redo this one. Well, I can of course do this. I can trigger this. I can give or retract the God mode and die. And now it will be finished once it reloads the map. Now this one is finished as well. And I assume I can now open the elevator. No, that's so weird. I don't think I'm missing one. Am I missing something here? So those two are done. No, this one isn't done. Okay. This is level Regulation Control Center. Regulation Control Center. Here, number 6. And it is indeed number 6. Okay, I'm not in God mode. So number 6, yeah, that should be the last one. And then the rest is going to be in the other part of the level, of the map. Reload Regulation Control Center. Let's finish this one. This looks like something, yeah, we have to go up here because there's arrows there. We just have to find the thing, the trigger. Duplicate the keys, and then maybe this one. Yes, go up here. Is it just for the gem? And go a bit farther here. Okay. Through the door. Damn. I assume it's the blue one over there. Well, can I clip? It was C, right? No. No, doesn't matter. I can't remember the key for clipping. I guess we'll have to find the switch, the toggle switch. Maybe it's that one over there. Yeah, probably. Oh no, it might be. Yeah, no, that's for the platform, the moving platforms, I'm assuming. Not for this one. Yeah, I think it's still there. Or did I forget about this one? Yes, I did. And then the blue one over here opens the door, and I'm strapped again. Up, more up, even more. Damn, another one. Probably this one here. We have 3 fuses. I hope we can break them. Yes, we can. That we don't have to use the Shikari mines. So I'm assuming that the elevator will open depending on whether these 4 things are fixed or whether these 4 levels are completed. Oh, wait, I see something here. So these aren't booleans. This is hex E. This is not just a simple boolean. That's interesting. Oh, okay, so it opened up and oh no, I'm at the bottom of the level. No, now the elevator is opened up. But these aren't booleans anymore. I didn't see that. This is hex E, which is 15, 14, 15. That's weird. we're gonna have to replay one of those to see whether it's. I mean, what would be the difference, right? What would be the difference between 1 and E if you just have to figure out whether the level is finished or the fuses have been burst? Like, what difference would that make? I don't think you can exit a level without breaking the fuses. So that's a bit weird. All right, so now we're here. This is the path to come back, I think, right? Yeah, the teleportation path. All right, so we go to level gravitational damping hub. That's 11. Oops. Okay. Let's find this exit. That was just for the green gem, I'm assuming. Where do we go? Oh, right over here. Then we can put this one on. I don't know what that's gonna do though. Oh, we can go up here. Let's turn this on just to be sure. Okay, a door. And the exit. Okay. So we haven't seen unknown 2 move yet in this one. Let's look at this one. So we haven't broken any fuses here. So I'm assuming this is just a Boolean and it's going to go to 1. Yeah, that's one just goes to 1. Okay. And then the last level, I assume, we have the hidden level too, right? So I think there was a hidden level. And I forgot to look at the name. I think, yeah, it was Quantum Explosion Dynamo. For this one, we need the Shikari mines, I think, to complete the level, as we can't jump with the pogo stick on the fuses. So this is 12. Okay. We have to go get the gem with the dogs. I think I can just go straight to the exit here. I think I know this level a bit better. Over these guys. And then with all the gems. And then get the Shikari mine. Of course, the game is going to finish now and everything is going to reset. So this is not really necessary. Is he coming? this one. Of course, he misses. Stupid. All right. So this bull does not get set, but because the game is over, everything will reset, I'm assuming. Yes, everything resets. So that's a bit unfortunate. I mean, it is level 12, of course, so that's fine. We just have to figure out these XE values. And we didn't see unknown 2 either. That's also weird. Why would there be a value here? Oh, there is a thing over there. I didn't see this one at the bottom here. How do I get? Is that the secret level over there? So this level 13. I don't know how to get there. Only be accessed by way of the gravitational damping hub. I know the trick how to get there with getting pushed off the thing. So I guess I'm gonna have to do that just to get there, because I don't know how else to get there. Which I can try now. God mode is still on. With these guys here. And he pushed me off. He pushed me off. I don't know if that killed it. I don't think so. Yeah, Cora 3, yes. So now we are still in Omega Matic. So we're still on the overview map. We finished level 1. That's good. Okay, let's see. This is secret Cora, the Cora 3 base. And this is level 13. Right, XD. Okay, now we can finish this with the fuse, because there's one fuse here. As we can see here. Yeah, there's one fuse. I don't know, does it have it has a regular exit too, I think. Not sure actually. Yeah, well, the exit is over there. But that's fine. I don't know if it's explained if that fuse actually has a thing. Right, so this transport thingy is unlocked now though, and I don't see unless it checks on this variable, because this has OE as well. That's a bit weird. So I think it was at 1 when I finished the level. I'm gonna have to do that again, because yeah, I didn't look at the value, because if there's a difference between 1 and hex E, meaning hex E is you opened the elevator. I don't know. Let me restart. I'm going to do the same thing and look at the value before I go into the elevator, because I didn't look at I did right before. Yeah, these guys here. I hope that's enough ways of getting pushed off. Come on. Yes. Okay. Cora 3 base. So now we have to look at this one here. Oh, it's immediately hex E. It's immediately hex E. It never was 1. It was immediately hex E. That's interesting though. So, yeah, because this doesn't change anything. Now, I wonder if the elevator opens, so we can test that though. Let's go easy game. We can test if this becomes hex E, whether the elevator opens. I guess we have to run through the first level. I'm gonna put this on hex E already, so that's when we exit this level. I'm assuming the elevator is gonna open already. So let's just finish this one regularly. Let's see if the second elevator is open now. Oh, I have to play. Yeah, I have to play through another one. Was this up or down? I can't remember. This is for the gem. Right, we have to open this one. Okay, we're back at the start. Oh yeah, here it is. Okay. Up. That's for the thingy. I need to give myself the key card. All right, let's see if the elevator is open now. It is not. That is weird though. Also, can I reset values when I go through the elevator? If I do this, does it reset the levels? No, it does not. It sucks that like in Keen 6 you could just reset or reload the map by going to the ship. I can't do this. This is annoying. Now, of course, I can just force these values to hex E and see if the thing opens, but I doubt that it will do that like just like that. So it wasn't the defense tunnels, it was these guys in between, I assume. And this one, maybe this one too, I can't remember. Yeah, so this is not going to open unless it was this one too. I don't think it was, but yeah, so this doesn't give me. Now, of course, we can do one of these levels and see if now the thing opens up, because these all have hex E, but I think they need them. So let's just play one level and see if it works. Because we have to determine what opens the elevator, because that has to be in the save game. We have to be able to, or the game has to be able to figure out whether to open the elevator or not. And I don't. The only thing it can depend on is whether the levels have completed, unless there's a value we're not seeing, which I doubt, because we looked at the game state in the save game file, and that appeared to be complete. So yeah, no, you have the key card. All right, so these are all finished now because I've put that. Yeah, now okay. So the elevator is determined by these 4 guys being on hex E. The only weird thing is if you go to corrupt 3, and only this one is open. That is a bit weird though. We can figure that out, but fine, I guess. We haven't seen Unknown 2 though. Unknown 2 hasn't been modified, and I played through the entire game. What did we miss? Not sure. Okay, so let's save the game. We're going to look at the save game file again, and then we're going to see if we can find the entities. In 5, save game 2. So we have our file header, we have the title, we have the game state over here, then we have the level data for a long time, and then at the end here we have the entities. I'm assuming it's the same as Keen 6. Yeah, so we're in the overview map, so there are very few entities. These are about right here. Let's say these guys. As you can see, they all have we see the same repetitive pattern again of blocks of, I'm assuming, size 4C. 4C size is the exact same as an entity in Keen 6, so that would make sense. I'm going to copy over the struct of Keen 6 and see if it matches. We just have to find them in memory and find the first one. So this one, and so I don't know exactly where the thing stops here, the level data stops. But I do know it starts with the type. Yeah, it's going to be this one, because I think hex 2 is the type of Keen. Yeah, so if we look at the structure of Commander Keen 6, we look at the entity. So it starts with the entity type and it ends with 2 pointers because it's a doubly linked list. It ends with the previous and next pointers to the previous and next entity. But the first one is the entity type, and I think it was 2 for Keen. I have a list here of entity types. Yeah, Commander Keen was number 2 and the camera was number 1. So I'm assuming that this one is indeed, so after this ABCD data, CDAB, which is indicative of the compression used for this block of data. And then after this, we start, I think, here. And if you go 4C bytes, 4C is about here. Ah, yeah, that's not B0. It's not, so it doesn't really start there exactly. Oh, yeah, no, here it is, here it is. 0202, yeah, that's the first one. Because if we go 4C bytes, this is here. Yeah, and then, so we have keen in the first. The 2 indicates this is entity type 2, meaning this is keen. And then the next entity type is 1, which is the camera, which comes after. So we know where the first entity starts here. All we have to do now is just search in memory for this data. Of course, I drag it off screen. And then 000001. I think I put one too many. Right, so this is the start of the entities list. Now we will copy over the entity structure of Keen 6, considering it's the exact same size in memory. I'm assuming we can just start at least copying over this this struct. Yeah, we're in structs here. So we have an entity. Now we can restore our entity pointer here. And we need the entity list. So yeah, which enums do we have? We have entity types, standing on and idle state. Idle state is not, that's not, it differs per entity, so that's not a very good one to list in the thing. But standing on we can take, because that's probably going to be the same. I don't know, we might not have conveyor belts. Do we have conveyor belts in Keen 5? I'm not sure. So we have standing on, and then our enemies themselves, the entity types, which are going to be completely different, of course, in this game compared to Keen 6. So, because we don't have these enemies, of course. I mean, the stunner shot might be the same, but it's fine. We don't have these guys. Okay. We will be able to fill these in as soon as I make the level editor or the save game editor for this one. Then we can easily see what ID or which ID corresponds to which entity type. Because it's a bit hard to determine that in the game itself. Okay, let's see. Oh yeah, we just have to add our symbol itself. We are in the same base 3813, and we are at address 8891. So we have a list of entities at 8891, which is the address at the bottom here, and these are our entities. And this is an entity array of, let's say, 100 entities. I have to use a fixed list. Of course, I can't dynamically allocate or assign the amount of entities. So after the exact amount of entities, there will be just garbage entities, but that's fine for the visualization in my little debugger here. That doesn't matter. Right, the facing directions also have an enum. Forgot about that one. Yeah, it's these guys here. Let's copy these as well. I'm assuming they are going to be the same, and if they are not, then we'll just change them. All right. Sprite info. Oh yeah, sprite info. That's something I haven't figured out in Commander Keen 6. So we're just going to do this mystery struct. We're going to remove that one, and sprite info. Yeah, that's a pointer. but we're just going to ignore that one for now as well. And we crash. I don't know why we crashed. Oh, do we have a problem with the thing again? No. Okay, never mind, I guess. So we have entities. Oh no, we do have a pop error. I popped too many times. That's weird because there's nothing. This one we have. U16, bull 16, U16, sign 16s, U16s, all fine. Oh, entity pointer. Yeah, no, they are good. They are good. I did change something in my code today in the debugger thing, which leads me to believe that this is the cause of that. I'm popping too much in symbols table. Let's debug so I can get a better stack trace. No, not that, not that. That, yes. Okay, no, it's downloading stupid stuff that I don't want. Okay, let's crash again and see if I can see this stack better. In symbols 900, I'm popping over there. Okay. This one is too many. That sucks because I think I will have it unbalanced if I don't pop here, because this one is matching with this one here. Oh, but I'm pushing ID seed here. That's not correct. Yeah, I don't think that's correct. I don't think I have to push ID seed here either. Let's try it with a mismatched push and pop. But this is not correct either. So I think I have to remove this one as well, because my IDs are not in ID seed anymore. They are in the physical address. So I did change that today. I hope this works. Damn, it doesn't. I mean, that's not a big deal. I'm just going to change it into not having an array then. Yeah, let's ignore that for now. Not a big deal. I can look at that later. I will just force it to not use an array then. Then the problem is solved as well, or should be solved as well. If I just do make a new struct. No, it's type is entity. So we have 11 entities, and that shouldn't crash because now we have eliminated the array. Why is it giving me 100? That's not correct. Am I in the wrong thing here? No, key 1.5. Oh yeah, no, entity list. No. I have to do this on, of course, as entity list, not as the array. Right. Right. No crap. Is there still an why are we still in that code though? We're not using an array. Draw symbol row. Oh, it's a different location. Change symbols for 410. Now it's this one. And here I'm pushing row ID, so that should be fine now. Yeah. Okay, let's just look at the graphics then. That's fine. All right. So I'm gonna put this back on what it's supposed to be. And remove our entity list. That's fine, I guess. I mean, I guess I can do, I don't know, if I do one entity, it's going to crash as well. So no, never mind. Let's just look at the graphics now. So we have to extract all the graphics from Keen 5 as well, just like we did for Keen 6. That means I have to clean up all the hard-coded stuff for Keen 6 and try and figure out how to parse it for Keen 5. So we have an EJ graph file, a game maps file, and the executable. We don't have a dictionary, a Huffman decoding dictionary. We don't have, well, it's embedded in the file, of course. So let's start by extracting the executable. It may not have been bigger. So this one, yeah, so on LZXC for the file. Right, so this is it renamed my files, of course. This is the extracted version, and this is the original version. I'm going to change it so it runs the extracted version. Oops. Let's see if that still does its thing. We'll stop here and restart. Yeah, that still works. And now we're running T5X. Okay. Which means we can now open Keen 5 in Ghidra and in our hex editor. So now we have the extracted one. Let's open that one in the hex editor. Okay, so we have our decompressed. Wait, let me open the other one too. to see if it's different at least. Yeah, this one is the compressed one, and this is the uncompressed one. Right. That's good. And this one is the compressed one. We can't find anything in here. Yeah, okay, that's good. Then let's see what we need to find, right? So we have to start with EJ graph, which contains all the assets, right? All the pictures and images and tiles and sprites. So for that we need, let's see, in the constructor here, load picture table entries goes to, no, first we need, what was it again? Oh, the EJ head file, which we don't have, I think. Yeah, we don't have EJ head, so let's go look on the wiki. So EJ graph is the thing we're looking at, containing all the actually these sprites here on the right are the ones we are looking at or looking for. So we have to start with EJ head, which is the 3 bytes indexing into EJ graph, right? 3 byte value in exit, but we have to find it in the executable, as opposed to in my Commander Keen 6 version that I used. We had a separate EGA head file. Yeah, I had a separate EGA head file. So if you look at that one, I think we can detect that one too. It ends with the same thing, I think. Was it these guys here? Not sure. Let's see what the wiki says, because I think it has an instruction on how to find the thing in the executable. So maybe present as an external file, or maybe included in the exe. The last entry in the header is always the same of the EJ, always the size of, okay, the size of the EJ graph file. Let's verify that. And the first entry is always 000. Okay, so we know, oh no, we can't know this size. We don't know how many there are. So you search for the file size as 3 byte little endian value in the exe. And then to find the start, go back 3 bytes at a time until you get to 000. Okay, that makes sense. So let's look at the size of the EJ graph file. I didn't have to do that for Keen 6, of course. So let's look at 6 first, which is 464662. 464662 in decimal. 464662. Correct, right? 464662. And then that is in hex, is that 071716. Yeah, and that's going to be correct. Yeah, so let's open then EGA head. Did I already? Yeah, so this is Commander Keen 6 EGA head, and the last bytes are 071716. Yes, 071716, and it's these three guys here. That are indeed those are indeed the last bytes. And if I go look in the Keen 6 executable, see how many matches I have for those 3 bytes. So we have to swap them around because of endianness. We search for, oops. So 16, 17, 07. No, was it this way or the other way around? I can't remember. It does find this though, and that looks to be the Huffman table. Yes. And do we have another one? No, there's only one match. That's of course coincidence, right? Because it's depending on the size of the EGA graph file. That doesn't mean that it can't clash with another 3-byte sequence in the executable. But for Keen 6 it works already, apparently, so that's fine. Now let's look at Keen 5, where we only know the size of the file, which is, so EGA graph is 572. Where did this one go? Oh, GX crashed. Okay. So now we have the size is this in decimal, which is 8BDF4. 8B, so 08BDF4. And now we'll look for that in the executable. Keen 5 executable, open with hex editor. And then we search the other way around, F4 BD08, which is found, is in the same, you can immediately see the same structure, right? Like it's at the end of the thing. Okay, there's only one match. It's at the end of the thing here. This is clearly the Huffman table we need. Okay, so that's not too hard to figure out. I'm gonna have to write code for that though to extract that, unless I just figure it out here. There's gonna be like 5,000-6,000 entries, so this might be quite a bit to find the zeros. It's gonna be this one here, right? Yeah, this is gonna be the first one. Yeah. I mean, I could extract it and hope it works. Yeah, let's just, okay, let's, yeah, it's going to be correct. Yeah, this is going to be the thing. Let's see if I can extract it programmatically. Okay, so this is in our Keen executable. We're going to remove the namespace Keen 6 because it's not just Keen 6 anymore, it's just Keen, as we're including other keens now. So version is going to be, we're going to add a version, Keen 5, and this is version 1.4. Then these are the map head offsets. So yeah, let's make a thing that has the size of EGA graph. Version to size T of right. So and then we store Keen 5's size as this one. Well, I mean, no, let me just do it in decimal because that doesn't matter. EGA graph, it's this size. That's easier. I can just copy paste that from the thing here. So now we need to extract the EGA head. So what do I do with EGA head here? I have slot count. I need to, yeah, I need a different constructor that constructs from memory and just assigns these guys. Yeah, but this is fine too, of course. Yeah, this is going to be the same, and then yeah, we can extract our slots. Okay, that should be fine. This should return a vector of, actually we should do bytes, right? Because this expects data is here in, is a car pointer because it's a memory map file. So it is a uint AT vector where we extract EGA head. We're going to do a very inefficient search, but that's fine. We have the version stored, so we know the size. Is this one at a version? I'm going to assume that the version is like that we have all the graph sizes in this map, which we don't, but that's fine. We're just testing with Keen 5 here now, so that's fine. We need to go to the save game thing, which is still called Keen 6, but that's fine. This has changed to Keen. Yeah, this is unused, that's fine. Yeah, that's just an unused problem. Now we need to search from in the entire thing, right? So let's see if we can find the offset in our mdata. So we loop for mdata size. I'm going to subtract 3, so we don't, well, no, it's fine. It can crash. If it doesn't find it, it'll crash, but it's fine. That's fine. That's not going to happen because we know this is correct, right? This is fixed data. Should we reinterpret this as, well, no, we can't because we don't have a type for that. As 3-byte values, I was going to say, but we don't have a type for that. This is fine, then I guess we'll just let's print these values. So I'm sure we are searching for the correct bytes. In the main, we're going to load our main. We're going to not do this. Path the save game file. Do I open the executable here somewhere? Yes, I do. This is just some test code in the main, if I have to test the specific thing. So we have an executable, we have Keen 5 extracted, version 5. And then we are going to extract EGA head, right, see if that compiles. And then we'll see if that unused parameter argv, fine. All right. I need to copy the executable over. That's fine too. Because I don't have a hard-coded path in there, I think. Yeah, it was just key 5x in the thing next to what I'm running, which is fine. I'm going to this one. Right, that's my guard here that we don't need. Now this one is also unused. Oh yeah, I should copy the file to 16.5 extracted exe here. That's what I put in the thing, right? Keen 5x exe, okay. All right, searching for these guys. Let's double check if those are our values. Checking for 08BD F4, 08BD F4. And it was in that order, I think, that we have to check. Yeah, F4 BD 08. Yeah. So it's in this order. So byte 1, 2, and 3 is in that order they should appear. So now we just loop the data size, and I'm going to go. Can I go 3 ahead? No, I can't, because I don't know where the EGA head starts in relation to the first byte of the executable. So I can't skip 3 at a time. But that's fine. I mean, it's like 200 kilobytes. That's going to fly through. No big deal. So if data at I equals byte 1, byte 3, then we have found our match. Yeah, that would be the match. And I think we can, I mean, we could skip 3 bytes here, of course. Could we? Oh, no, no, that's just, let's see if we can find it at least. This is not an optimal way of searching through things, but sure. Car alongside int. What is this? Okay, this should be an uint 80. I don't think this is. Okay, this is unsigned long. All right. We didn't find it. Of course we didn't. Byte 1, byte 2, byte 3. And what is this data type? Car. Would that be, is that's signed, right? So that might overflow. That for all, I mean, it's stupid, of course, but let's make them the same type. Data 1 equals at least they're casting the same, so we don't have any casting problems or signedness problems. I don't think this is going to fix it though, but oh yeah, it does. Okay, so 28AE9 does that match our result here? So the F4 is where it stops, right? This is at 2889. It's probably hard to see, but in the bottom left corner here, I can see my index, my position, and I'm at offset 2889. So we did find our end. That means that the end position is this +2, right? Because we have to chop out the EGA head file, meaning we have to know the end position as well. Okay, so we have to find EGA head start and end, and we can set end here to I +2, because we have to include the next 2 bytes as well, of course. And now we will go back. So if EGA head end equals 0, we just throw an error, because, I mean, it's not going to happen, of course, because we know it's in there, and we know we can find it. This is not going to happen, so that's fine. And now we go from this point 3 at a time forward, like or backwards, I guess, in the file. And we just have to find 3 consecutive zeros, but they have to match. Yeah, we can't just look for 3 consecutive zeros, because they might occur in 2 overlapping positions, right? 2 overlapping sets of 3 might have 0, 0 and a 0 from the other one. So we have to jump back 3 at a time, right? And we start here. So we start here in this one here, and I just have to go 3 back and check these guys. 3 back and check these guys. Okay, so this one, we start at the end, which is already in the first position of the 3 bytes. We stop at 0, and we go 3 at a time, right? And then we check. Oh, we simply check out those positions, because that's aligned. Then yeah, it is aligned for sure. Because if we start at this correct position, yeah, if we start at this correct position, and we do -3, -3, then yes, it's always going to be aligned. Okay, so we just have to check. Same thing here. That's the exact same thing. And now we have to just check for 0 instead of actual bytes. And then we have start equals I. We don't have to add 2, because we have to start at the start of the thing, right? And then let's see if we can match what we see in the hex editor. Okay, which is EGA head start. Okay, dump some statistics here. Let's see if we find it. Right, so 14 kilobytes of data. And we start at 2511F. Let's see if that is correct in the hex editor as well. So this is our end. And then we go all the way up. Where's my thing here? Oh, here it is. All the way up to where it starts, which is, yeah, this is still part of it, right? Yeah, this is still part of it. Oh, this is not part of it. Let's just go, oh no, these are zeros too. Oh yeah, here it is, here it is. I think this is the one. Yeah, because here it starts. Yeah. So this is the first 3 bytes. So it would be this one. This is at 25120, and we have 2511F. 2511F. Oh, it's a bit before that. That's weird. 2511F. This one here. Wait, was I that wrong? Oh, yeah, no, it's okay. It's one off. Yeah, I said this one is 25120, which is one more than 1F, of course. Yeah. So I'm off by one. Because, yeah, because of that last. I mean, I can just add one, of course. I mean, it probably makes sense though if I mean, I did add 2. Oh, does this add another? Does this X? Yeah, I think this one executed, so it incremented. No, because this one is the final one. I add 2 and I break, so this one doesn't execute anymore. That's a bit weird. So this one is definitely correct. Right, so let's see if this, yeah, 28 AEB. I didn't double check that, but is there a jump here? Jump to 28 AEB. It has to be hex. Yeah, that's indeed the last byte of the thing. Right, yeah, we're just off by 1 because of it's end minus start. We have to count either both the end or either the end or the start, right? I think that's the problem. So we're ending at this one, but we might have to. Yeah, this is we'll just add 1 to the start and see, and if we extract, we'll see how good we are here. So no, +1. Let's do it like that. That should make sense, right? Yeah, 25120 to 28 AEB for 14795 bytes. And if we divide this by 3, we know how many sprites or how many chunks we have, which is oh, that's not good. That's not a round number. Wait, no. This is not the chunk. No, this is not the chunk thing. This is the Huffman table, right? No, this is not. No, not at all. Well, how can this not be divisible by 3 if we're checking sets of 3 bytes? That's not correct. How is that possible? So 2510, 25120. Right. Let's so 25120 plus, I have to put that in decimal. No. In decimal plus our size plus 14795 back to hex is 28 AEB, which is correct, of course. It's a length of 39 CB. If we start here, okay, it's just not going to go any quicker. Oh, I can't shift click. Okay, that's stupid. 28 AEB. How is that not divisible by 3 though? That's impossible. Unless I am off by 1 again. Yeah, 14796 plus is divisible by 3, and that's 4932. So that does make more sense. I'm off by 1 again, which means my end is wrong. Yeah. So the end is 1 over then, I guess. Yeah, this can't be divisible by 3, of course. Well, never mind. I think I have to do this. Do I still have to do this then? Yeah, because otherwise I end up with the same thing. Right, that's definitely wrong. This is quite a bit too much here. Why? What happened here? That's weird. Oh, wait. Because now the values are one apart. Oh, no, no, no. Oh, no, plus 2. No, no, I needed to... How is that wrong? How does that screw up the values that much? That's so weird. Oh, right. So because we do start at EJ head end, right? So our whole offset changes, right? If I do 3 here, I have to add 1 or subtract 1 from this one, I guess. Yeah. So we start at 25, 120. Which is here, which is correct. And we have a length of 14796. This is going to be correct. And then 28 AEC is the end. That's inclusive. It's like, it's the difference between including the first and the last or not. That's my problem here, which is fine. So we know the length, and we know the range it exists in, meaning we can now pass that on to our EGA head constructor. We just need to add this is also not in the Keel 6 namespace anymore. We just add another constructor that takes in a vector. And then we just assign this to, can I copy that into a, oh, that's a pointer. Yeah, because I memory map that thing. That's fine though. I can just point that at the vectors data thing. That means we do have to store it. You may have to make a copy of that, which is fine, I guess. I hope this works. Why aren't you auto-completing? Okay, so we make a copy. We have the data. Why aren't you? Is that already a pointer? It is already a pointer, I think. Yeah, it won't do that. I hope I can static cast that. I don't think, maybe I have to reinterpret cast that. Yeah, that's not gonna work. Then we just have to force it, I guess. And EG head was not found. Okay, now I'm problems because I changed the namespace. Now I have to, I guess I have to change all the namespaces then, just to get rid of that problem, which is gonna infect everything. Okay, we're compiling again. Very good. Now let's see if we can, in our main, we can load EGA head. From our vector instead of straight from the separate file. And let's dump something from EGA head. The slot count should be like 4,700 or something. The amount of chunks in our file. Right, I can't unmap. I forgot to do that. So we have 0 here. That's not good. First, I have to make sure I don't unmap the data read in EGA head. No, not this one. EGA head. You have to store. So in this constructor, we set that with true, and then we check at destruction to unmap only when we mapped. That goes away. My slot count is not good though. Slot count should be divisible by 3. Data size over 3, so data size is incorrect. What do we assign here? Data size is 0. That's not good. Why is it not? Oh, did I not return this from the executable thing? Map head, extract EGA head. Oh yeah, I didn't insert. Wait, why am I returning a vector here? Yeah, I do have to, right? Yeah, I do have to, because this is empty. I've never filled this in. That's why it's returning 0 or returning an empty vector. Yeah, we do have to, we determined start and end, but now we have to actually copy this data. We're going to inefficiently copy that. I think we can use that copy too, but wait, I do have a memory mapped thing here though, actually. So I don't need to copy this to a vector. I have already memory mapped this. I can just get a pointer to this data. Yeah, that might be better. Instead of accepting a vector here, let's just do this and the size. And instead of doing this, we just set just to be sure. And we set this to data and data size. This pointer is going to stay good because we won't throw this thing away in main. Like this XA is going to exist when we work on this file here, so that's fine. And then this extract EGA head just needs to return the pointer and the size. So instead of this needs to do a pair of a pointer and a size t. Extract should return this, right? We have a pointer and a size, and what we do is we return and data plus our EGA head start and EGA head end minus EGA head start is the size. That does not work. Do I have to do make pair? Yeah. What's wrong? Could not convert. Which one is complaining about, the size or the... I guess it's the pointer too that it's complaining about. And data is a car. Oh yeah, it's a car thing, right? That's probably why. Yeah. So I shouldn't do uint 8t then, because I'm reinterpreting in EGA head, which I shouldn't do if I accept a car pointer. Yeah, it is already expecting a car pointer because of the memory map file. So I should leave it in as car instead of accepting a uint 8t. This is a const pointer, which is fine, right? I'm not going to change that. I'm just going to read from that. I am going to assign it to a regular. Maybe it's going to have a problem with that. Yeah, I think it does. Yeah, of course. I mean, it's fine. We're not going to touch that anyway, but it's fine. This should work now, at least. Right, it does. And then this one, we have to these error messages, like quite verbose. So couldn't convert a car pointer reference. Why is it a car pointer reference? Long instance int reference. Are these references here? No. Let's be more explicit then. No, car pointer. Oh, I forgot to change this, of course. This needs to return a car pointer as well. Okay, this seems to work now. Let's just clean that up again. All right, and then we just have this problem here. Yeah, we need this size as well. So this becomes the data and EGA at size, and then we pass this as well. Right. What do we have now? 4,932 chunks in EGA graph. That's good. That's good. So now we have a functional EGA head, which we can now use in. So that is this. We have our chunk count. Let's just keep that. Right. We have our slot count, our chunk count, and then we need to. Yeah, we need an EGA dict as well, which we also have to extract from the executable. That's the next step, because so we have an EGA head file, we have an EGA dict file. So the head is the offsets of the chunks, the dict is the Huffman dictionary, and we combine those in EGA graph, which we read in, and then we pass both the Huffman dictionary and the header to so we can index chunks. So we need to extract the Huffman dictionary now. There was also a trick to finding that, which was if we look at the Huffman dictionary in Keen 6, it was, what was it? Yeah, it was something at the end here that we could figure out. I think it's FC01, FD01, that is typical for the Huffman dictionary, but it's also documented in the wiki here. So it's this section here. Note that the EGA dict file is not often obvious, usually embedded in a file in the main executable. Probably it's possible to locate it by looking for the string FD01 000, okay, which appears at the end of nearly all Huffman dictionaries. FD01. Oh yeah, it's these guys here. It's these 4 last bytes or these 6 last bytes. We are going to find multiple though. Yeah, executables usually contain more 2 or more dictionaries, but the EGA dict is usually the second one. We're going to accept for Keen Dreams, but that's fine. Yeah, so a simple check of whether it decompresses the data sensibly works. I mean, sure, but let's go for the second one. But we have to find that in the executable as well. So we have to search for this, FD01 and 4 zeros in Keen 5 exe. So if we look for FD01 in one, oops, FD01, yeah, 4, right? So we have 1 result, and this would be our dictionary. So that was the first one. Then the next one, oh, we only have 2, okay. And it's going to be the second one, I'm assuming then, that we need. Also, there are supposed to be 100 entries, or how many were there? Okay, 1024, right. So add 6 and subtract 20, 1024. So it's 1024 bytes. Okay, it's 1 kilobyte. Then that's easy, right? Because we can just subtract 24, add 6 and subtract 1024. Okay, let's do that in code as well, in the executable. So it's going to be similar to extract EGA head. To extract EGA dict. For this, we need to know, no, we don't need to know a size, because that's not the parameter we're looking for. We have to do something similar here. Okay, we don't need this factor anymore. This is an unused thing. So, I mean, I can do it the exact same way, right? And then, except for this part here, we don't need this part because it's 1024 bytes, so that we can just subtract. So EGA, we have dict start and end. Then byte 1 is simply, it was FD01, 1, right? So FD. Actually, let's just put that in a little array here so we can loop. Uh, 01 and then 4 zeros. And then we loop the entire thing. And then we check for 6 bytes and see if they all match, right? So let's just copy that. This stupid pop-up. Right, so we have our 6 bytes. Actually, let's loop this because that's dumb. We're just gonna loop. We have to do this 6 times, right? So we don't write all that out. And then we do assign it to uint 8t. Yeah, to get rid of the sign it. Yeah, we don't want sign problems. So d equals m data I plus j. Then we have this part, and then we have to keep track whether it's a match or not. We have to assume that it's true, and then fail if it doesn't match. So if d not equals bytes to search at j, then match is false, and we break. I think that's correct, right? Then so we loop 6 times, we get the correct byte, we have to check, and we check against the correct index byte in our bytes to search. If that doesn't match, we're false, and then if we have a match, then we can, we have to, because we have multiple dictionaries, right? So we have to do this twice. This should be a vector then, I guess. Let's do a vector of pair where we have the start and end of both dictionaries we encounter. So the end is I plus 6. I could be off by 1 here again, though. I think it's plus 7 then. Right, because, I think it's plus 7. We don't break here, but we do insert in our thing here. Can we just immediately? Yeah, I think we can, right? So end equals this, and start equals end minus 1024, right? So it did say to add 6. Add 6. We'll see how it works out. We can always adjust where necessary. So does this work? Does it accept this? It works, okay, and then that's fine. Let's print this out. EGA dict found from, do I still have the thing here? No, I removed that. Found at this one, X08 to here. I'm gonna calculate the size again. It should be 1024, of course, but just to be sure, we'll see if that actually is correct. Oops. What's wrong here? Oh, do I know? No, right. I don't know. No. No. Don't know what I was thinking here. Who is complaining? Oh, no, return statement. Right, now we have to, I think I have to store this as well per version to indicate which, which is the correct EGA dict index, right? And for this one, it's index 1, as in the second one. Right. And then we return, well, let's just extract these values first. First, we'll double check if EGA dict.size is smaller or equal than, let's just get the index first, index so we know which index it is, and it should be bigger, or the size should be bigger than EGA dict index, right? Otherwise, we're going to have a problem. All right, and then we extract these values. Start and end equals EGA dicts. Let's just this one, and then we return the pointer, right? Yeah, and the pointer and the size. And we return and data. How did we return that here? Yeah, this one here is what I need. This one and data plus start, and this is 1024 hard coded. Okay, let's see if this works. So extract EGA dict, we need to add to our thing, right? EGA dict data and dict size. Let's print it out here as well. Well, no, we don't really need to. No, we don't need to because we're printing it out in the other one. Just extract it. This is unused, of course, which is fine. Because we're going to give that to the constructor in a moment here. So we have found two, but oh yeah, this seems to be correct though. So we have, because they were right next to each other in the executable. If we looked here in the, see, they are, we see them both here, but the two red things are the ends. So we have one here, and we have one, and the next one here. So at 39025 is the start here. Should be this one here, 39025. That is not the start. Oh no, wait. Yeah, no, it's this byte. Yeah, so this probably is something else, and it does start here. So if I go to FD, yeah, and then these guys here, this is 3 FF bytes, which is one less, of course. Like I have to count to here is 400 hex, which is 1024, right? 3 FF and 400. 400 hex is 1024. Okay, so. And my size calculation here was the subtraction of those things, right? Not my hard-coded value. Yeah, it's n minus start. Okay, and then that means it's going to take index 1, which is 39425. Oh yeah, so this is what I meant by the problem, right? This goes from 39025 to 39425, and this starts at 39425. So that's why I had that little thing with being off by 1, but it's fine. We know the start points, so 39425 should be the correct start point for the next one. So after these 4 guys, it should start here with this 96 here, and that's 39424. Damn. Why am I always off by 1? That's so silly. It is off by 1 though. It should start. Oh, is this the 7? Did I do the 7? Let's try the 6 then. Yeah, this is better. The size is still correct, but now we end at 24 and we start at 24, which is what I'm seeing in the hex editor here. So we have FD100, FD01 and 4 zeros. So 96 is the first byte of the next one, of the next dict here, and that starts at 39424. So this is what we need, 39424. Okay. That means that now we don't need to do this, or I guess I can leave it as a comment. Now we can use that information and feed that to our Huffman constructor, because this one needs the dictionary, right? The Huffman file here. So yeah, dict path, we need another one that is exactly the same as EGA head, where we give it pointers, and then we can work with that as well. Right, so let's implement that. It's going to be the exact same as this, right? And I have to add the isMapped file as well. Otherwise, we're going to unmap a file that wasn't mapped. That doesn't matter because we do set that in both constructors. What are you complaining about? Mdata, mdict data, of course. Okay, so now we can pass our embedded dictionary to our Huffman thing. EGA dict data and dict size instead of a hard-coded file. And now we have a Huffman decoder with the correct data. What can we ask here? We can't really, yeah, we just have to, we don't have a test function to see whether it works, but I'm assuming it does. We'll see that when we extract things, of course. This one we don't really need. That's for testing the save game itself. So now we have an EGA graph. This file we do have, and then we have EGA head and Huffman. So let's see. We're in the key namespace. We have EGA graph.ck5, which is a file we have, of course. Yeah, EGA graph.ck5. We have to copy that to our working directory though. Yeah, now we have this one I'm just putting that next to the executable to make it easy. Also, can I remove the 6 from the name here? yeah, just name it key save game. Unknown target, why are we... Oh yeah, my target is incorrect here. Keen save game. Right, now it's just keen save game. And we're sec faulting. Okay, fine. Why does this not work? We're giving it EGA head. We're giving it a Huffman thing. Now we have to see why it crashes here. Okay. So we're in load picture table entries, right? So we're actually doing the same decoding as keen 6 now, which this might be different though. So we're in the constructor of EJ graph, and I think that immediately calls, yeah, load picture table entries. Wait, did I forget to? I forgot to adjust the destructor of this guy here. Forget that. So load picture table entry, that should be the same though for keen 5 and 6. So I don't know why it's complaining about that. Because yeah, so for example, keen 4 has chunks as sprites. Okay, that's fine. We're just reading the picture table, so why would that not? Let me dump that too. I mean, we're crashing before this, but then at least we'll see something before we crash. So we're crashing in the Huffman thing, right? So load picture table entries. This should be a very easy thing, though. That's weird that this doesn't work. So EGA graph, load picture table entries. These are cleared. Chunk 0 is requested. Let's dump these values. So output is chunk 0. What does this again? Okay, that's the vector containing the data. So let's see how big it is. The chunk size is this, and picture count equals this. Oh, it doesn't even go that far. We're crashing before we... Are we crashing in the Huffman thing itself? I mean, yeah, I guess it's in the chunk function, which does the Huffman decoding, of course. Yeah, the crash happens here. So in the chunk function here. So we're asking for offset 0 or index 0. Okay. Let's log what gets requested and what comes out. Okay, offset is 0. That would be strange, but possible. Unless my Huffman table is actually incorrect, though. It might not be the second one in the list. I'm going to dump the Huffman table to make sure I'm not off by 1 byte or something. So 1024 bytes. I'm going to print a byte out with a space, and that would be mdata plus start plus I. Actually, that's a pointer, so we have to dereference that. Right. And then if I plus 1 modulo 16 equals 0, we print a line. And then at the end, we print a line as well. So we don't mess up our lines here. Let's dump our Huffman table. And let's see, so it ends with FD01 and 4 zeros, that's correct. And we start with 96, 93, so that's correct though. So we end with FD01 and 4 zeros, and we start with, what was it here? 9693, so where's the FD01 here? So it should be around half here. Okay, let me highlight them. That would be easier. Yeah, the 96. So 96 is the first byte until here. So that seems to be exactly the same, right? 96, 93, 9D. Yeah, that's correct. And we end with FD01 and 4 zeros. So this appears to be the correct Huffman table, if it is the second, of course. We can try with the other one, but I don't think it should crash, even if it has the incorrect Huffman dictionary. That is a bit weird. So at least we're sure that the Huffman thing we're extracting is correct. I'm going to try with the other one, with the first one in the file. You never know, but I don't think it should crash though. Yeah, it still crashes. So I don't know if this is correct. Let's dump out the chunk offsets. I could start with chunk 0 at offset 0, but I mean, yeah, it could be. I don't know what that is. What that is for Keen 6. I can't remember. Yeah, I did try this, right? So yeah, let's put that on 1 again. Let me see again where it crashes. So EGA graph 69. EGA graph 69. Which is the chunk request, I guess, while Huffman decode. The decompressed size. Oh yeah, the decompressed size. We can figure that out too, because the decompressed size is the first 32-bit value of our chunk itself. So when we are dumping our thing here, right? This guy here, chunk 0 requested. We can dump the size as well. Oh, right. This is Keen 6 specific. Right, I have to be careful with this here. But we don't even get this far. How is that possible? So chunk 0, does this not flush? No, it should flush, right? Yeah, this doesn't even print. How is that possible? Because we are crashing here. So this is definitely a potentially like a thing that's Well, so what happens is there are certain chunks that don't have a decompressed size in front of them, but they are like outside of this range. We are here, right? So we are in requesting index 0, and we are outside the range because it's less than 1 before. So we are definitely looking at the first 32 bytes to find the size of the decompressed data. So we are here. This one prints. Wait. Oh no, did I? Oh no, I did. I was wrong. I was wrong. This does get printed. This does get printed. That is this one. Offset is 0, so this doesn't trigger either. Let's see if this works. Right, so now we have, okay, so here we know the decompressed size. Okay, so let's print out a decompressed size by doing this, which I had from previous testing. 372. That seems fine. I mean, I am loading the correct CK5 file. That's so weird. Let's skip chunk 0, and let's go to chunk 1, because we can see if we see different values here. So we have 372 as a size. The second chunk contains the masked picture table entries. So we can see if we can parse that one. So instead of this, we do this. We skip our picture table entries and we go to the masked picture table entries, which requests chunk 1, right? So let's see if that works. I mean, it's going to crash the same way, of course. Yeah. So the offset is indeed now better. Yeah, offset 2 to 6 and decompressed size is 12. This looks low. This is the masked, because these are pairs. This would mean there's only 6 in there, because these are pairs of 2, a width and a height, and so 2 per set. Well, I mean, it could be. So we crash while getting the chunk in 69. Yeah, we saw that, right? EGA graph 69 in the chunk function. This is the chunk function. 69 is in our while loop. So we're calling Huffman decode. We have a correct size. So max amount of characters to decode is 372. That's fine. We're in the decode function. Current decoding node is the right node is I mean, there's 1,024 nodes in the tree. How can that fail? So I'm currently coding node is null or something, right? Because it's trying to dereference this thing here. While this is false. We are in line 78. Yeah, it's this guy that falls. So we are going right. It's supposed to go right, but it cannot. That's so weird. And we do check. Right, so if it is no, then we are setting it to the root node, which is the last one, I believe, right? I can't remember exactly how it worked, but I think that was the last node. Yeah, create node 254. So we have 1024 bytes, but they're 16-bit, right? Wait, I have to check again how that worked. The Huffman table. Does it say here? Numerical list of nodes. Yeah, we had 3 bytes, I think, or do we have 4 bytes? Starting with node 0, ending with the root. So the root would be the last one. Each node takes up 4 bytes, right? So we have 1024 over 4 is 256. Yeah, 2 bytes per branch, right? So we have we have 1 byte if it leads to another node or a character, and the other byte in the identify the node of the character. Yeah. Why would that fail? So we are in crashing in. Yeah, so this is null at this point. How can that be null? So create node is 254 as an index. Node info of 254. So if this actually is null, I don't know if that's the case though. Let's see. Yeah, so that would mean that the root node is null too then. Oops. Let's dump this as well. Can I just do a unique pointer like this? No, I can't. I don't know what the thing is for printing a that should work, right? Why is this code not working? Let's just do it old school then. Is it %p? I can't remember this by heart. I guess we can do x. Why are you not? This gives me a node pointer, which should work though, right? So it expects argument type of unsigned int, but argument 2 has type unique pointer. Okay, so can I static cast this to a one point? I don't think so. Just reinterpret cast, right? I have to reinterpret this. I just want to see if it's 0. Why are we? Well, P is for the void pointer. Okay. Does this work then? And this is complaining about that probably. Okay. Yeah. Okay. So this is null. Yeah, that's impossible though. That's not good. So the root node should be set, right? Why is it 254? 0 to 255. Why is it not? Is the root node not the last one? List of nodes ending with the root. Why is it 254 and not 255 then? That's a bit weird. I don't know why I put 254 there. Wait, yeah, it's 256 is the max, right? Yeah, so that's still weird. Oh, of course. I'm using a different constructor in which I don't set the root node. Of course. There we go. Okay, this is fine. This is because of the Keen 6 stuff. Yeah. Okay, now we're getting somewhere. That was dumb. So we're reading out chunks here. That's good. Yeah, that was stupid. Now what we have to do is go here. So this is causing an issue. We have to reverse engineer the Keen 5 executable to find the same function that determines which of the chunks do not have the decompressed size in front of them. But that's fine. We can just not do this yet and start with picture table entries and see if we can get those out. Yeah. So here we go. Now this is our picture table entries. So we have the decompressed size of 372. We have a chunk size of 372. We have 93 pictures, and these are our pictures, right? So that's good. I think we can do the next one. So the only thing where this matters, where we have to look in the executable, is for the sprites, for the tiles. So I think we can do more than this. We can load the sprites as well. Yes, we don't crash, and that means we can dump the sprites as well, I think. So we don't dump the picture tables, but we do dump the sprites. This is just a sprite table, though. These are not the sprites themselves, I believe. Yeah. So this is a sprite table for Keen 5. So we have 345 sprites. So these are positions and offsets of the hitbox. Like the clip rectangle is the hitbox, I think. And the widths and the heights. Right. What else can we see? The font count we can see as well. I don't think I printed to the output, so let's do that. Font count is being printed. Okay. So we have 3 fonts in there, same as Keen 6. I think I wanna take out this print one though. Oh, I want to put that one in a comment in case we need it later. Okay, so we have font count 3, and then we need, yeah, so this one contains all the the tiles and the sprites, but we have to not do everything then. So let's do the pictures first and stop here and not do this yet. All right, let's see if we can do pictures first. All right, we have the pictures extracted. Yeah. So we have output now. Let's check our pictures that we have just extracted. So it already extracts the pictures that are in EGA graph, because that's just the same thing as Keen 6. Right, so these are the extracted pictures. So yeah, that's the thing here. Let's see if we can find something cute. These are just the stuff that's on these info or help pages. Right, end of text. Also some previews of all the guys here. Shikadi Master. It's software. Yeah, these are, so this is for the pictures that are shown, right? Those are this is Keen Bordeaux. I don't know why that's in there. Visa card, MasterCard. Keen himself. Yeah, this is the little animation at the end, I guess. This is the letter that you have to decode. With the baseball helmet. With the MM for Mortimer. Whatever it was, I don't remember. The Christmas cap on. Congratulations. These are the parents. The parents are in 6, right? Alien is it my babysitter, I think? Or was it this one? Is it in 5 or 6? I can't remember. Yeah, this is the promotion for 6. Main menu. These are the menu pictures. This is the wrist. It's software production, the credits. And this is the title screen. And the Galaxy 2. Some Keen. These are the things when you finish a level, I think. The countdown. Game over. That's it. Those are the pictures. The unmasked pictures. Let's see if I can. Yeah, so we have the masked pictures as well, but those maybe not. Yeah, okay, those are that's the thing that comes down, right? And then the tube here. That's all. Those are only 3 masked pictures. Let's see what else we can extract before crashing. So these are the masked pictures. We have those, and then the sprites. Let's do the sprites as well. I don't think the sprites are. No, it was a 16 by 16 tiles that had the thing missing, the prefix missing. Well, we do crash here. Let's see if we have extracted any sprites. Yeah, we did. Let's look at the sprites. So this is Keen, all the Keen positions. Reading his book. Surfing. Death animation. That's his shooting. This is on the map. Then we have the points. These are the Vitamin things, I think. like the drink. That's the barrel for the one up, I think. Then the gems, we have the gems in all the colors. The gun, the thingy at the top left, the HUD, the blast. I don't know where that is exactly. Well, that's on the overview map too, right? It has to be. That's the flag, the rotating flag, the keen thing. Don't know where those explosions are exactly. Oh yeah, those are between the thing, right? And this little fella in the hidden level. Then the Shikadi master, or whatever he's called. He looks angry. Those are his things that he shoots. The doggy. The mine thing, I don't know what his name is. The little robot thingies. The Shikadi mine. Exploding. This guy. Oh yeah, this probably, so this doesn't look correct anymore. So here's gonna be, this is where it crashed, I guess, because this is not correct, right? This should be this guy, I think. But for some reason, this fails, and I don't know why that would be the case. But anyway, that's something we can figure out next time. Once I figure out where it crashes, then we can have a look at that. So I guess this is it for today. We did extract quite a bit already. We just have to fix some small crashes, and then we can extract the rest and the tiles, and then we can integrate that into our save game editor. I can show that off. If you haven't seen it yet, so we have a save game editor here on the website. Here. So there's an example file you can load where you can edit all the values. This is only keen 6 for the moment, but we're working on adding keen 5 and 4, etc. also to this editor. So you can change all the values, and then you can change which levels you did. And then when you drop a level, you can actually modify the stuff inside the level. So you can take this guy here, there's Blue, and you move him around, and you can add, if you want a Blooglet or another Bloog, for example, you can just double click and it adds a Bloog for you. So you can edit the levels a bit, the save games at least. Yeah, and then you can download your thing. You can see some information. You can see the hitboxes and stuff, and the info plane. So that's the point of adding all this to our current save game editor. So that's why we're extracting all the graphics data right now. And then we'll incorporate that, including all the prep, the details of the save game file itself, of course. If you want to see how that got made, you can watch the YouTube video or read the blog post about it. I've put it in a blog post as well, but there's a YouTube video as well, which I'll link to. And then you can watch that if you're inclined to do so. I think that should work. if it wants. Yes. All right. So that was it for today. Thanks for watching, and I will see you next time. Bye.